Oh, that's strange. Okay, ready? Okay, so start with two-sided limits. Okay, that's what a two-sided limit is going to look like. And again, you got to understand how to read that and what it's asking you for. This is asking you, as the x values get closer and closer to a on either side, what are the y values? In other words, the f of x values approaching. That's what it's asking you when I write something like that. Okay, and again, the mistake that students make is pointed out here in the note. Okay, so it's very important that you are not focused on, what the y value is at a, but rather what the y values are approaching as you get closer to a. Now, they might be the same thing, they might not be the same thing, but don't always focus on what the y value is at a, because that's not always your limit. Okay? Now, what's the difference between that, which is a two-sided limit, and something like this or this, which are one-sided limits? Well, you see the difference. Kind of like as an exponent, so to speak, you see a little plus or minus sign. What the minus means is that you're only worried about what the y values are approaching as x gets closer to a from the left. This one-sided limit, which is the right-handed limit, with a little plus sign there on the a, means what are the y values approaching as as x gets closer to a from the right side. Okay, so the minus is left side, the plus is right side. Okay, and then in summary, if you want to find the two-sided limit, what you need to do is you often need to find the one-sided limits first. Okay, if those one-sided limits are the same, say L for example, then that's your two-sided limit. If the one-sided limits are different, then what? The value of the limit does what? Does not exist. Okay? Okay, so that's just an overview. Okay, now I'm going to take you through how to find limits in many different ways. Are you ready? Okay, you're going to have to know all the different ways, and you got to know when to use what method. Okay, so here's some of the methods that you can use to find a two-sided limit. Okay, suppose you have the graph of the function. Well, that's the easiest way, because all you got to do then is look at what the y values are approaching as x gets closer to a. Is that clear? So if I have the graph, or if I give you the graph, or you could easily find the graph, that's an easy way to find the limit. Method number 2 is using a what? Table. Okay, so again, if you have a table of values, you can often just look at what the y values are approaching as x gets closer to a again. Okay, method 3, try to analyze what's going on. In other words, sometimes you can just look at the function, study it, and analyze it, and maybe figure out what the y values approach as x gets closer to a. Okay, so these are all the different methods you're going to need to know on how to find the limit of a function, right? Got it? All right, now this is the one you're going to use most often. Okay, it's by substitution. Okay, so here's what's going to happen. In fact, I'll put this as C here. Okay, if you get a value, you're done. Okay, if you get a value, okay, so again, what you're going to do is you're going to take A, okay, you're going to take the A and substitute into the function. If you get a value, you're done. That's going to be scenario C. Okay, that's the easiest thing that's going to happen. If you get a value, you're done. Okay, if you don't get a value, here's something else that you might get. Suppose you have a fraction and you end up with 0, 0, 0 over 0 after you substitute in that value. Well, if that's the case, then you're going to have to try one of these other methods, okay? Because think about it. Aren't you stuck when you get 0 over 0? Now, I know 0 over 0 is undefined, but that doesn't mean the limit does not exist. Don't fall into that trap. So again, if you get 0 over 0 when you substitute the a value into the function, it does not mean, that the limit doesn't exist. It just means you're stuck. And so how do you get unstuck? Well, again, by one of these methods here. You can factor or FOIL and then try the limit again. You can rationalize the numerator or denominator and try and find the limit again. You can clear out a complex fraction and try again. You can get a common denominator. So there's all kinds of little simplifying and rewriting techniques you can try. But you should only do those if you get stuck with a what? 0 over 0. Okay? All right, another way you might get stuck is with like a non-zero over 0. So suppose you get like 5 over 0. Okay, you are stuck again, but you're stuck in a different way, right? Because that would fall into this category, non-zero over 0. If that's the case, if you get a non-zero over 0 after substitution, then you know your answer is either this, or it does not exist. Okay, and to figure out which one it is, you just plug in decimal values very close to A. Okay, now I know I'm throwing a lot out there at you, but don't worry, I'll go over all of these one at a time at some point today. Okay, I'm just kind of summarizing it up front so you have everything in front of you to pick from. Okay, and then we'll just do a bunch of examples. Ready? Okay, here it goes. All right, so example 1, I give you a graph of the function here. Okay, I'm giving you the graph, and I want you to, and by the way, I made a couple notes here. There are vertical asymptotes where? At -2 and 1, as you can see, and there's a horizontal asymptote at what? At y equals 2, which you can see. Okay, and by the way, just a quick note. Note how a graph can cross a horizontal asymptote, but you should also know that it will never cross a vertical asymptote. No big deal, I just thought I would point that out. Okay, so here we go. Looking at the graph, guys. By the way, these go on and on like this. There should be arrows here. Okay. Okay, so looking at that graph, you should easily be able to find all these limits here, A through P. Are you ready? Ready? Here we go. Okay, in part A, what am I asking you to find? The limit as x goes to what? -2, and here's -2 right here. So in other words, by the way, I'm only asking you to find the limit from the what? From the left, because you see that little minus there, kind of looking like an exponent. So this is saying, as x approaches -2 from the left, what are the f of x or y values approaching? That's what this one is asking you, right? So here we go. As I approach -2 from the left, do you agree I'm right here? I'm at all these points here? Okay, so as I approach -2 from the left, what are these y values approaching? Infinity. Everybody agree it's positive infinity that the y values are approaching? Okay, what about B? This is asking you, as x approaches -2 from the what? From the right, what are the y values approaching? So here we go. As I approach -2 from the right, do you agree I'm looking at all these y values here? What are they doing? Approaching what? Negative infinity, correct? You following me, guys? Pretty easy, right? All right, now look. What did I just find? I just found the one-sided limits as x goes to what? -2. So now you should be able to easily find part C, which is the two-sided limit as x goes to -2. So if the one-sided limits are different, right? The left-hand limit is positive infinity. The right-hand limit is negative infinity. And when those are different, the two-sided limit cannot exist. So it's what? Does not exist, right? Think about it. If the one-sided limits are different, then the two-sided limit can't exist, right? Does that make sense? They have to be the same in order for the two-sided limit to exist. Got it? Okay, what about C? This is asking as x goes to -1 from the what? Left. So here's -1. As x goes to -1 from the left, what are the y values approaching here? They're approaching that open circle. And what's the y value at that open circle? 1. So even though there's an open circle there and you never really hit 1, can't you say the y values are approaching 1? Can't you? And that's the answer. Okay? Okay, what's this asking? What are the y values approaching as x goes to -1 from the what? From the right. So as x goes to -1 from the right here, aren't you at all these y values here? What are these y values approaching here? What are they approaching? -1. Okay, and again, now that I found these one-sided limits, you should be able to use them to find the two-sided limit as x goes to -1. Since these are different, the two-sided limit what? Does not exist again. Make sense, guys? Okay. By the way, before I forget, if you have a question like A or B on tonight's homework or on a future test or on the AP test, technically, these limits that approach infinity, negative infinity, technically those don't exist either. Because technically, to exist, it's got to go to a number. Now don't worry, I won't put d and e and infinity as both answer choices. I won't do that, okay? Got it? I'm just saying if you've got a bunch of answer choices, right, and one of them does not exist and a bunch of numbers, then obviously these would be what? These would be what? Does not exist, okay? Because again, technically to exist, the y values are supposed to be approaching a number. So again, I'd rather you put infinity or negative infinity if that's actually what it's going to instead of does not exist. But this one clearly is what? This does not exist because these are different. Is that clear? Good? You understand? Okay. All right, where was I? G. Okay, this is saying as x goes to 0 from the left. Okay, look at as x goes to 0 from the left here. Do you agree? You're looking at these y values here? What are these y values approaching? Guys, as x approaches 0 from the left, the y values are approaching what? Negative 2. How about this? As x approaches 0 from the right, what are these y values approaching? Negative 2. And since those one-sided limits are the same, what's the two-sided limit as x goes to 0? Negative 2. Are you following me? Okay. Let's look at J, guys. You tell me. As x goes to 1 from the left, what's the limit? Quick. What is it? Negative infinity. Good. How about as x goes to 1 from the right here for K? Negative infinity. And since those are both negative infinity, what's the two-sided limit here as x goes to 1? Negative infinity. Okay, let's look at M. This is saying as x goes to 3 from the what? From the right side. Okay, so here's x equals 3. As x goes to 3 from the right side here, what are the y values going to? 0. Even though there's an open circle there, the y values you can say are still approaching 0, correct? Oh, I'm sorry. Yes, sorry. From the left side, they're approaching what? 0. How about from the right side? 0. And so what's the two-sided limit? 0. Everybody see what I'm doing here? Yes? Okay, now this is different. What's different about P? This is saying as x goes to what? Infinity. In other words, if you kept going here and here and here, right? As x goes to infinity, what are these y values approaching? Well, obviously they're approaching that asymptote, which is at what? Y equals what? 2. So you agree that in that case, the y values are approaching 2? Even though they never hit 2, they're approaching 2, right? Okay, good. All right, so that's one example where I give you a graph. All you got to do is look at the graph and say what the y values are approaching. Okay, now, I want you to take note here, guys. We're going to talk about vertical asymptotes for a minute, but let me back up. Okay? What did you notice? Every time there was a vertical asymptote, what were the limits? Either what? Infinity, negative infinity, or does not exist. Did you take note of that when we were doing that a second ago? Okay, so that's what I'm talking about here. Okay, so anytime you have a vertical asymptote, the one-sided or two-sided limits will be either infinity, negative infinity, or you can add in what? Does not exist. The one-sided limits will be infinity or negative infinity. But the two-sided limits could technically be does not exist, right? Got it? Okay. All right, so what's strategy number 2 for finding a limit? Well, using a table. Okay, and if I give you a table problem, I'll probably give you a calculator. Now, you have some like this on your homework tonight, and you have some on the next test, which actually comes up pretty quickly because I fly through Chapter 2. So, and trust me, I'm going to give you problems that you won't be able to do any other way. So you're going to want to learn to do it this way on a calculator. So here we go. Okay, so if you have a calculator or you want to come get one, that's a good idea. Okay, first of all, look how I set up the problem, because I'm not always going to set it up for you. So if I give you a limit like this, and I say, go ahead and use a table on a calculator, this is what you want to do. First of all, you want to set it up as I point out there in my hint. Okay, so here we go. So everybody find table set. Where's table set? Second what? Window? Okay. Independent, that's x, right? Don't we want to put in our own x values here, right, as x approaches 2? So put that on ask, so that means you can put in your own x values. Now independent, you want to leave that on auto, because that will automatically calculate the y values for any x values you put in. So when you're finding limits on a table, on your calculator, make sure you go to table set and change these. Okay. Now go to table by hitting what? Second what? Graph. Okay. All right, so you should now be able to put in any values you want. Now, look what I picked. What are these? By picking these values, I'm picking x values that are getting closer and closer to 2 coming in from the what? Left. Okay, so as I go this way, I'm getting closer and closer to 2 from the left, and when I go this way, I'm picking x values that are getting closer and closer to 2 from the what? From the right. Okay, do you understand? Okay, so here's what you want to do. Put in 1.9 and hit enter. Then put in 1.99 and hit enter. Put in 1.999 and hit enter. So right now, oh wait, I didn't put in a function. Stop, sorry guys. Clear those out. I might have the wrong function. So hit delete, delete, delete. Sorry about that. All right, so let's back up a minute. Let's go to y equals and type in my what? Yeah, type in my function. Sorry about that, guys. Don't forget that. So what should I be typing in? Y equals what? X squared plus 1. Okay. Okay, so, all right, now we can go back to the table and start doing what I did a minute ago. 1.9 enter, 1.99 enter, 1.999 enter. Okay, so as x approaches 2 from the left, what does it look like the y values are approaching? Looks like they're approaching 5, right? Yes? Okay, you can do a couple more if you want. All right, now be careful. I'm just typing these in order, but if you think about it, you kind of have to read this part of the table from the bottom up, right? Because when I go from 2.1 to 2.01 to 2.001, that's when I'm getting closer to 2 from the right, yes? So as x approaches 2 from the right, what does it look like the y values are approaching when they go from 5.4 to 5.04 to 5.004? Again, it looks like they're approaching what? 5, right? Okay. By the way, notice I never really need to put in 2, do I? No. Okay, are we good? Okay. All right, that's one method to find that limit, okay? Now, I'm going to give you another method. Another way you could do it is using a what? A rough graph, just like you did back in the summer packet, right? You draw a rough sketch. You should all be able to draw a rough sketch. Okay, so what are we graphing? We're graphing the function what? Y equals x squared plus 1, which we all know is a what? Parabola, opening, up, shifted, 1 unit, up. Okay, so if you quickly draw something like that, by the way, the vertex will be here. Give me another point. 1 comma what? Plug it in. Plug in 1. What do you get for the y value? Quick. So I'm just getting some more points on my graph. Okay, give me another one. When you plug in a 2, what do you get for the y value? 5. Okay, all I'm doing here is getting a couple points on my parabola graph, and I'm going to draw my parabola. Okay. So there's my parabola. And you should be able to just look at it now. As x approaches 2, which is right here, as x approaches 2 from the left, looks like the y values are going up to what? 5. How about from the right? 5. So do you agree it's 5 again? Just finding it a different way. Got it, guys? Can you see it in the graph? Okay, what's another way? Substitution. Now, again, if substitution works, this is probably the way you want to do all limits. Okay, so what do I mean by substitution? It's simple. Just plug your x value in there. When I plug in a 2, what do I get? What do I get? 5. So again, if you try substitution and you get a number, you're done. That's the limit. You don't have to do any other method. So that technically should always be your first method, since that's the easiest method. Right? Good? Okay. All right. Now, for example 3, we've got to change the function, because now we're finding what? That limit, right? Okay, so clear that out. By the way, some of you struggled on that nasty function on the summer packet test, and I think it's because you guys didn't use the fraction feature. Where's the fraction feature on your calculator? Anyone know? It's under alpha y equals, and then you can choose different options. If you choose option 1, that's your basic fraction. That way you can enter a fraction without having to worry about a bunch of parentheses, right? So please know that you hit alpha y equals and choose option 1 to put a fraction there. Okay. All right, now what? We're going to go to the table, right? So hit second, table, and hit delete, 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 delete. Okay, so what are we going to type in now? Well, we're trying to find the limit as x goes to what? 0. So notice what I picked. Do you agree by picking those values right there? So negative 0.1, enter, negative 0.01, enter, negative 0.001. Do you agree by picking those? I'm getting x values that are getting closer and closer to 0 from the left. Do you agree that those are good choices? And what's happening to the y values? They're going to what? Negative infinity, right? Do you agree? It looks like, I mean, you can do a couple more if you want, but I think it's pretty clear that the y values are going to just keep going to negative infinity, aren't they? The closer I get. Okay, how about from the right? Be careful. I'm going to just type them in how I have them in the table, but you can type them in any order you want. So do you agree I've got to read the table from the bottom up? So from the bottom up, as x, in other words, as I go this way now, as x goes to 0 from the right, what are the y values approaching if they go from 10 to 100 to 1,000? Hello? Infinity. Okay? And so since from the left the y values are going to negative infinity, from the right the y values are going to positive infinity, what is the two-sided limit here? What's the two-sided limit? Does not exist. But if I asked you for the one-sided limits, you would give me either infinity or negative infinity, right? Okay, easy, right? Aren't limits easy? They are. But you just got to know all the different strategies. Okay. All right, now how are you going to do this using a graph? Well, the function is what? The function is y equals what? 1 over x. You should know it looks like what? You should have this memorized. What does the function y equals x, 1 over x look like? It's a hyperbola where? In the first and what? Third quadrant. You should know that. You should have that memorized. But let me get some more specific points. Okay, when I plug in a 1, quick, what do I get for the y value? 1. What about when I plug in a 2? What do I get? A half. What about when I plug in a half? What do I get? 2. So that just gives me some y values to work with. Okay? And then how about when I plug in a negative 1? What do I get for the y value? Negative 1. How about when I plug in negative 2? Negative 1 half. How about when I plug in negative a half? I get what? Negative 2. So again, looking at the graph, as x goes to 0 from the left, what are the y values approaching, guys? As x approaches 0 from the left, what are these y values approaching? Negative infinity. How about as x approaches 0 from the right, guys? Positive infinity. So what's the two-sided limit? Does not exist. Okay? So again, Doesn't matter if you use method A or method B, you should get the same answer. Do you agree? Okay. All right, now, here's the tricky part. Remember I said you should always try substitution first, since that's the easiest method? So suppose I tried substitution here by plugging in the 0 into there. What would I get? I'd get what? Well, what do I get? Yeah, I get undefined, but what kind of undefined? Do I get 0 over 0 or non-zero over 0? I get non-zero over 0 because I get 1 over 0. Do you agree? By substitution, when I replace the x with 0, I get 1 over 0, which falls into the category of non-zero over 0, correct? You guys staying with me? Okay, go back to the first page. What did I say? When you get a non-zero over 0, what's the answer? It's either what? Infinity, negative infinity, or does not exist. Now you got to figure out which one of the three it is. Are you ready? Let me show you how to do that. Okay. Let's figure out the left-handed limit. In other words, just plug in like negative 0.01. If I plug in negative 0.01 there, again, I don't want a value. All I want to know is this whole thing positive or negative when I plug in a negative 0.01? Tell me. And why did I pick negative 0.01? Because it's close to 1. I'm sorry, it's close to 0 from the left. Okay, so if I plug in like negative 0.01, is this whole fraction positive or negative? Negative. And since I know it's got to be infinity, negative infinity does not exist, I know it's got to be negative infinity. Okay, how about when I approach 0 from the right? What are you going to plug in there? Like maybe positive 0.01, because that's close to 0 on the right, isn't it? Again, I don't want a value. I just want to know, is 1 over x positive, negative, or undefined when I plug in a 0.01? Positive. So guess what that limit is? Positive infinity. Again, I know it's got to be one of these three. I already said that. Once I run into non-zero over 0, I know it's got to be either infinity, negative infinity, or does not exist. Is that clear? Okay, so if those are the one-sided limits, what's the two-sided limit here, guys? Does not exist. So I just showed you 1, 2, 3 different ways to get that limit correct. Okay, so if I give you a choice, it's up to you. Okay, but in some cases, I might tell you what method to use. Okay, are we good? All right. All right, now, don't panic when you see this long list. After I go through them quickly, most of them are just common sense. Ready? Okay, so what are these limit laws? Okay. Well, first of all, I want to say the easiest way is what? To find a limit is what? Substitution. But as I said earlier, sometimes I get 0 over 0, which means that you will what? What did I say earlier? When you run into 0 over 0, what are you going to have to do? You're going to have to simplify or try one of these tricks. Is that clear? So that's where I'm at now. Okay, so if you get 0 over 0 when you try substitution, then chances are you're going to need to do one of those factoring, foiling techniques or rationalizing, okay, clearing out complex fraction, getting a common denominator, all those different methods I mentioned earlier. Now after you do that, you might need to try substitution again. And when you do that, it usually works. Okay? Now, the problem is, along the way, when using substitution, you might have to use some of these limit laws. Okay, so here they are. Suppose C is a constant. Okay? Rule 1, what does that say? That means if you're taking the limit of a sum, what can you do if you want? Yeah, take the limits separately and then just add the limits later. So the way I say that is the limit of a sum is the what? Sum of the separate limits. Okay, it works with a what? A difference as well. You can split a limit of a difference up into the difference of two separate limits. What does number 3 say? It means if you have a constant multiplied by your function, you can always pull the constant out, find the limit of the rest of the function, and just multiply by c at the end. Got it? So you can pull out a constant. What does number 4 say? If you have the limit of a product, you can do what? Take the limits separately and multiply the limits at the end instead. Got it? What does number 5 say? If you have the limit of a quotient, you can what? Take the limit of the numerator and divide by the limit of the denominator, if that makes it easier, right? Okay, well, number 6, what does that say? If you're taking the limit of something raised to a power, what can you do? You can take the limit of the inside of the function and then just raise that limit to the power at the end. Got it? Those are brackets, by the way. Got it? These are just little tricks and laws. All right, what does number 7 say? Well, if you're taking a limit with a radical, if you want, you could take the limit of the inside of the radical and then just worry about the radical at the end. Right? No big deal. And then finally, this is the easiest one, but it's the most valuable one. Don't forget it, ever. What does it say? The limit of a constant is the constant, no matter what x is going to. So I don't care what x is approaching, the limit of a constant is always the constant. Memorize that. Got it? All right, that was easy. Okay, so let's go to example 4. Again, very, very easy. Just follow along. Ready? Okay, I'm telling you that the limit as x goes to some value a is 5. The limit, and that's of f. Okay, the limit of some other function g as x goes to the same value a is -3. So knowing those two bits of information, you should be able to find the following limits. Are you ready? Okay, so how do you find the limit of f plus g? Well, one of your laws says you can just what? Take these two separate limits and what? And add them. So what do you get? 2. Very easy, right? That's according to one of your limit laws. You can just add those two values, right? Okay, what about b? What can you do with the 2 according to one of your limit laws? What can you do? Well, you can pull it out, right? And then just take that limit. And what is the limit of f of x as x goes to a? What is it? 5. So then you just do what? Yeah, 2 times 5, and that gives you what here? 10. Does everybody agree that the answer to b is just 10? Okay. All right. What does one of the limit laws tell you can do with something like c? You can split it up into what? The limit of f times the limit of g. And when you do that, you just get what? 5 times -3, which is? And 15. Okay. Is there a limit law for something like d? Yes? What does one of your limit laws allow you to do here? It allows you to take the limit of f divided by the limit of g. In that case, it would be what? 5 over what? -3. So your answer is -5/3. Pretty easy, yes? Heads up, guys? Heads up? Okay? All right. All right. Look at example 5, guys. I'm asking you to take the limit of a sum and a difference, right? So according to your limit laws, what can you do? You can take the limit of what? Each piece separately and then just add those limits or subtract them at the end, right? So you agree I can technically split it up into that limit minus that limit plus that limit. Do you agree? Yes? Okay, and by the way, try and find the limit by substitution. What do you get? If I plug in a 2, what do you get? Come on. What do you get? 8. Okay. All right. How about this one, guys? Technically, what can I do with that 6 here? I can what? I can pull it out front like that. And then, can I just plug in the 2? When I plug in the 2, what's this limit here? What's the limit? 2, and then times the 6 gives me what? 12. And then how about the last one, guys? How about the last one? The limit of a constant is always just the what? Constant. So what's the limit of 3 as x goes to 2? 3. And then if I just add and subtract at the end, what's my answer? -1. Okay, so technically my limit laws allow me to do all that, right? Split it up and find the limit separately, then just add and subtract at the end. However, back up, you guys. Back up. What if I didn't do any of that? What if I just took the original problem and plugged the 2 in right away? What do I get? If I plug in the 2 there and there, what do I get? -1. So again, what I'm saying is you don't have to split it up. Okay? You could split it up, but you don't have to. That's what I'm saying here, right? And so, again, if I give you a limit and I don't specify what method, what's always going to be your first method? Always, guys. Substitution. If you get a value, you're done. If you don't get a value, then you try one of the other techniques, right? Okay? Okay. I'd give you a break, but I'm recording it. Sorry, guys. We'll give you a break at the end, okay? All right, and it's strange. Once I stop it, I can't pick it up again. It would start a whole new video, which I don't want to do, so I can't stop it. Okay. Okay, example 6. What's it say, guys? Find the limit. So what's the first thing you always do when I give you a limit if I don't specify a method? Substitution. What happens when I plug in the 1 there and the 1 there? What do I get? 0 over 0. Okay, we're stuck, but we're stuck with which category? The 0 over 0 or non-0 over 0? We're stuck in the 0, 0 category. Okay? So what does that mean? There's usually some kind of what? Simplifying technique, right, that you should try. Okay, any ideas? Any ideas? Factor the numerator since it's a difference of squares. So if I factor the numerator, I get to here, and then I can cancel out the what? The x minus 1s. And after you do that, then you're supposed to try substitution again, and hopefully this time it works. So after simplifying, when I plug in the 1 again, what do I get? What do I get? 2. And so that's the limit. Pretty easy, right? Got it? All right, so get example 7. Again, first thing you're going to try is substitution. What happens when I plug in the 2 there and the 2 there? What do I get? What do I get? I get 3 over 0, which falls into what category? The non-0 over 0 undefined category. And so back up. What did we say at the very beginning of the hour? When you fall into this category, then the limit is either what? Infinity, negative infinity, or does not exist. So knowing it's one of those 3 things, your job now is just to figure out which one of the 3 it is. And how do I do that? Guys, up here, eyes and ears up here. How do I do that? Well, yeah, since I'm asking you for the 2-sided limit, it's a good idea to find the 1-sided limits first. So here we go. And after I find the 1-sided limits, it should be no problem to use them to find the 2-sided limits. Or the 2-sided limit, I should say. Okay, are you ready, guys? All right, so here we go. We're trying to find the limit as x goes to negative 2 from the left. So knowing it's either infinity, negative infinity does not exist, all I got to do is pick something really close to 2 from the left. Like what? 1.9? So I put a 1.9 there and a 1.9 there. Don't go reaching for your calculators. I don't want a number. I just want to know whether it'd be positive or negative when I do that. So if I stick a 1.9 there, that's a positive on top. 1.9 there would be a negative on the bottom. What's a positive over a negative? A negative number. And so therefore, guess what your limit is? Negative infinity. That's all you got to do. Once you know it's either positive infinity, negative infinity, or does not exist. Okay, now I'm going to find the right-handed limit. So give me something really close to 2 on the right. 2.1. So if I put a 2.1 there and a 2.1 there, all I want to know is this whole thing positive or negative? Positive. So guess what your limit there is? Positive infinity. All right, now all you got to do is look at those, and that'll help you figure out what this is. Since those are different, what's your 2-sided limit? Does not exist. Any questions on what I did there? Any questions on what I did? No? Pretty easy, right? All right, let's look at example 8. By the way, I'm going to do this one on separate paper because I don't want to cram it in there. Okay, but the first thing you do is try what? Try substitution by replacing h with 0. So if I put in a 0 there and a 0 there, what do I get, guys? I get 0 over 0. Okay, so when we get 0 over 0, what's going to be the approach? We do what? Some kind of what? Simplifying or factoring or some kind of algebraic trick to try and get unstuck, right? Okay, so here we go. All right, let me write this down, guys. All right, any ideas? Any ideas what we might do here? Any ideas? What algebraic trick might we perform on something like this? Yes? The conjugate, right? Use the conjugate to rationalize, right? In other words, get rid of the radical. So watch what we do here. Multiply top and bottom by the conjugate here. So basically, to get the conjugate, you change that to a plus. Now, whatever you multiply the top by, obviously you got to do the same to the bottom to keep it the same value, right? Okay, are you ready? And again, I know the mistake you're going to make here. The mistake you're going to make is that you're going to distribute on the bottom. Do not distribute on the bottom. Leave it alone. So just leave the bottom as this. All right, now on top, you're going to have to FOIL, yes? But look at something, guys. Don't you have something kind of in the form a minus b times a plus b? Don't you guys, technically? Doesn't that fall into the algebra 1 situation where you're multiplying a minus b times a plus b? And what did you learn back in algebra 1? When you FOIL a minus b times a plus b, you always end up with what? A squared minus b squared, correct? Yes? Don't you? So without going through the whole FOIL, can I just say that a minus b times a plus b will be my a squared minus my b squared? Do you agree? And what's your a, guys? Your a is what? What's your a? Square root of what? 1 plus h. What's your b? What's your b? 1. Any questions on what you're seeing there, guys? So, I mean, you could FOIL, but why bother? You know a shortcut from algebra 1, right? Yes? All right, so let's just simplify this mess, and it should work out nicely now. Are you ready? Okay, so here we go. Don't the square root and square go away there? Don't they, guys? And then here, what's 1 squared? 1. Okay, any questions so far? Now what happens? Now what happens? The 1's go away. And then what? Then the h's go away. Be careful here. What are we left with now? You're left with 1 over this, aren't you? Okay, so after you've done your algebraic trick or whatever you want to call it, now you should try substitution again, and hopefully this time it will work, right? And you get a number and you'll be done. Okay, so what happens now when I substitute in the 0 for h? What do I get when I put a 0 there, guys? Quick. I get 1 over what? 1 plus 1, which is what? So half. That limit's a half. Okay, good? Good? Okay. Cruising right along. Let's go to example 9. Okay, again, if I don't specify a method, what are you going to do first to try and find that limit? Substitution. So what happens when I replace the x with 3 there and there? What do I get, guys? 0 over 0. Do you all agree you get 0 over 0? So again, there's going to be some kind of algebraic trick, hopefully now, to get unstuck, right? Because we're stuck right now with 0 over 0. By the way, that's called, the book doesn't call it stuck, it calls it indeterminate form, just so you know. Okay? I just used the word stuck. Okay, whatever. Okay, so how do we get unstuck? Well, again, let me do it on separate paper. I just don't want to cram it in there. You won't be able to see it. Okay, guys. What are you looking at here? Well, notice you've got fractions inside of a fraction. That's called the complex fraction. So the trick in this type of scenario is to clear out the complex fraction, and that should hopefully do it. Okay, and what did I teach you way back? Way back. It's only last week. But on day 1, how do you clear out a complex fraction? What's the trick? You multiply top and bottom by what? Whatever the inside denominators are that are causing the complex fraction. So you agree those are the inside denominators that are causing the complex fraction? So what would be the common denominator for those two denominators? 3x. So all you got to do is multiply top and bottom by 3x, and that'll clear out the complex fraction. Are you ready? Clearly I have to what, though? Distribute? Yes? So what do I get when I distribute? Quick. Help me, guys. You get, yeah, this times that gives me just 3, and then minus, what's 3x times a third? X. And on the bottom, just leave it alone. Okay, just leave it alone as 3x times that. Now, it'd be really tempting to to cancel out 3 minus x and x minus 3, but those are not the same thing. Are they? No. But didn't I also teach you another trick on day one? How do you turn around a subtraction if you want to? Yeah, just put a negative out front. So if I want, I can turn around a subtraction anytime I want as long as I put a negative out front. So I can turn that into x minus 3 as long as I put a negative out front. Is that clear? And by doing that, I can now what? Cancel those out. Okay, and so after you did the algebra, you should now try substitution again, and this time it should work, correct? So what happens when I put in a 3 for x right there? What do I get? What's my answer? Negative 1/9, and that's my limit. Okay, so there's another trick you got to add to your toolbox for limits, okay? All of these are going to show up on the next test, okay? And they're all going to show up throughout the year. Okay? All right, last page. Ready? Okay. This has not been covered yet, so just take note here. This is not a scenario that I've talked about at all yet. If you find those one-sided limits, hopefully you can then use those to find that two-sided limit, okay? Now, what happens when you try substitution, when you stick in the 0? By the way, for one-sided limits, you're also welcome to try substitution. And if you get a number, you're done, okay? Okay, so you can use substitution on one-sided limits just like you do on two-sided limits. Is that clear? Okay, so if I try substitution, what do I get? What do I get? 0 over 0, so I'm stuck. Now, here's the problem. There isn't an algebraic trick for an absolute value. Okay, so I got to show you something different right now. Okay, so this is the one scenario that does not fall into one of the categories that I covered on the first page of your notes. Okay, so you got to know how to handle this. Are you ready? It's really easy. So anytime, you guys, this not only goes for limits, this goes for anything you run into the rest of the year that has an absolute value. Your strategy is always going to be the same. Are you ready? When you run into a situation where you have an absolute value, here's what I want you to do. I want you to roughly sketch the function. So I want you to roughly graph the equation y equals absolute value of x over x. And how are you going to do that? Easy. Just by plotting some points. Now, I don't want you to randomly pick points. I want you to start and plot points around where it's undefined. So where is that undefined? At what? 0. So I want you to pick. Notice what I'm doing then. I'm picking points that are close to x equals 0, since that's where the undefined scenario happens. Okay, so what happens when I plug in a negative 2, guys? So if I plug in a negative 2 there and a negative 2 there, what do I get? Quick. I get negative 1, don't I? Okay, so plot the point, negative 2, comma, negative 1. Okay, plug in something else close to 0, which is where the undefined is. So suppose I plug in negative 1. What do I get when I plug in a negative 1 there and a negative 1 there? What do I get? Negative 1. Plot the point. Okay, how about when I stick in like negative 0.3? What do I get when I stick in negative like 0.3? That's real close to 0. What do you get? Negative 1. All right, so what's going to happen is it's always going to be negative 1, except when you hit x equals 0, it's undefined, so put a hole there. And by the way, this will keep going like that forever in that direction. So do you agree the y values will all be negative 1 in there? So that piece of the graph will look like that with a hole at 0, right? All right, now let's stick in some values to the right of 0, like 1 or 2. So what do I get when I stick a 2 there and a 2 there? What do I get? What do I get? Positive 1. Oops. So plot the point 2 comma 1. Okay, plug in, how about like 1? Plug in a 1, what do I get? 1. So plot that point. Plug in something real close to 0, like 0.4. What do I get? 1. So what do you think, guys? It's always going to be 1 out here, right? You agree? Except that there's going to be a what? A hole again where? At 0. So there you go. So the graph basically just looks like this. Yes? Doesn't it? Okay, now hard part's done. Now the easy part. Everybody just look at that graph and tell me, as x goes to 0 from the left, what are all these y values approaching here? Well, they're all negative 1, so obviously they're approaching what? Negative 1. How about as x goes to 0 from the right? Well, as x goes to 0 from the right, I'm looking at all these y values, and they're all what? 1. So obviously, if they're all 1, they're approaching 1, right? Okay, if that's the left-hand limit and that's the right-hand limit, what's the two-sided limit? Does not exist. Why? Because those are what? Different. Are you following me, guys? Okay? Okay, squeeze theorem. There are about, I don't know, 5 or 6 theorems you are going to learn this year. 5 or 6 major theorems. This is the first one. Now, when you guys go on in math, a lot of you will go into engineering. A lot of you will major in math, which means you're going to be taking a lot of math in college. And you'll find that the higher you go in math, the more and more jam-packed your textbooks will be with theorems. Okay, some courses will be nothing but one theorem after another. Okay, theorems sound very, very complicated when you start reading them. In fact, most of them sound impossible to understand. So one thing I want to teach you is how to break down and understand theorems. Are you ready? This is the key. When I give you a theorem, or when any of your future teachers or professors give you a theorem, the first thing you want to do is break it up into the if part and the then part. Now, I use bolded words there, but when you're reading it in a textbook, it's not going to be bolded like that. So that's the first thing you want to do is separate the if part from the then part. Okay? Now, ignore the then part right now. Just look at the if part. What does the if part of this theorem say? If what? F of x is less than or equal to g of x is less than or equal to h of x. Stop and think about what that means before you go any further. What does that mean? That means graphically the y values on g are in the middle of the y values on f and h, right? Does that make sense? So what that means is you got 3 graphs here. G is in the middle. And then f is the what? F is the what? Lower one, and what? H should be the what? The higher one. Isn't that basically what that says? I mean, they might touch, but basically G is in the middle, right? Isn't that what that says? Graphically, G is in the middle like that? Okay, keep reading. Now what? Okay, by the way, when x is near a, that's all it's saying is that holds true when x is near a. And there's another if part. And if what? Both what? What is that saying? The limit as x goes to a from both sides of f approaches the y value L. And same thing as x goes to a from the left and the right for the function h, that also goes to L. So what's that saying? That means as you approach a from the left and the right, the y values on f and h are both going to what? L. All right, so let's look at this now. Here's what we have. We have this, right? We also know what else have what? We have the fact that as what? As you approach a, what happens? The y value on what? On h and what? F go to what? Go to what? Go to some y value, what you can call what? L. Is that what the second if part says? That as you approach a from the left and the right, both these functions approach the same y value L. Is that what it says? And then what else did we just say a minute ago? G has to be where? In the middle of those two, right? So I don't know what G looks like, but it's somewhere in the middle, yes? Okay, so if you have those two if parts both being true, then the theorem guarantees something else will be true. What does it guarantee? What does it guarantee? That what? That G will what? That G will also approach L as x goes to a. And by the way, you can see that that happens. Don't the if scenarios squeeze G into also having the same L, limit L? That's why we call it the squeeze theorem. Right? The scenario here squeezes the function G into having the same limit L as x goes to a. That's all. That's why we call it the squeeze theorem. Got it? See how easy that was? Now, if you read that on your own, would it have made any sense? Probably not. Not the first time. Which is why, like I said, you've got to break it up into the if part and the then part. take it one piece at a time, and I think you can figure out what's going on every single time, no matter how complicated it gets, right? Okay. All right. So, what does that got to do with limits? Well, what does the squeeze theorem have to do with limits? Well, it can help you find a limit like that that would otherwise seem impossible. Are you ready? Okay, here we go. We're going to be done in like 5 minutes. Okay, let's look at example 11. All right, so I want to find this limit. And by the way, when you try substitution, you're what? You're what? Yeah, you're stuck in, right, in a strange way, because you end up with sign of undefined, and so you're stuck, right? And there's no algebraic trick here. Okay, so here's where the squeeze theorem comes in, right? Here we go. All right, let's break it down. Let's look at this. Let me just temporarily call that theta, okay? What do you know about the sign of theta from your previous math courses? It's always between what? -1 and 1, right? Always. It doesn't go up and down between 1 and -1, always? Okay, so is it okay now if I put the 1 over x in there? Is that okay? Yes? All right, now I multiply everything by what? By what? X squared. Okay. Okay, so at this point, let me simplify this. Okay. All right, now if that holds true, then if I stick these limits in there, that should still hold true, right? Agreed? I can just stick those limits in there, and the inequality should still hold true by common sense, right? Are you following me? Yes? Okay. All right, guys. What's this limit? Just by substitution, what is it? 0. What's this limit by substitution? 0. So guess what? If that's limit 0 and that's limit 0, it squeezes this limit into being what? 0 as well. That's your answer. So again, I started with a basic piece of knowledge about the sine function. I slowly built it up to the function I'm dealing with, keeping the inequality true, right? Are you following me? And then from there, just common sense helped me figure out what the limit was that I wanted to find. Okay? All right, the last 3 are very easy and we're done. Okay, try substitution. Boom, what do you get? Go, 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 go. By the way, let me use separate paper here. Okay, you get 0 over 0. Okay. Everybody agree you get 0 over 0 when you try substitution here? Yes? Okay. And we're stuck. So there's probably some kind of algebraic trick. What's the trick? Yeah, can I just FOIL x minus 3 times x minus 3? What do you get when you FOIL x minus 3 times x minus 3, guys? What do you get? X squared. Come on, quick. Minus 6x plus 9. Don't lose your minus 4. And then all over x minus 1. Okay. Simplifying this, I get the following. And then what should I do now? Try and what? Try and factor the numerator so I can maybe simplify this further, right? Okay, I need an x and an x. I need a what? 2 minuses, right? And a what? Quick. Come on. Okay. Okay, everybody agree it factors into that, so I can just cancel those now. And once you simplify, you always want to try substitution again, and this time it should work. And sure enough, it does. If you get a number, that's your limit. Okay? Good? Two more. All right. How about example 13, guys? What happens when you try substitution on example 13? Okay, hold on. Everybody agree when you try substitution on 13, you get 0 over what? Negative 4. What's 0 divided by negative 4? 0. You're done. Done with that one. Right? So what I'm saying is don't go jumping to factoring or anything else until you've tried substitution first. You might not even need to factor or do anything to it. Right? So always, always do what first, no matter what? Substitution first. Even on one-sided limits. Is that clear? Yes? Even on one-sided limits. That's always your first strategy. All right, finally, guys. Remember I said piecewise functions are going to keep coming up throughout the course and you can't be afraid of them? Okay, so this is saying you've got the function y equals x plus 3 for all x values less than or equal to negative 1. And then you've got the function y equals x squared plus x plus 1 for all x values greater than negative 1. So if I ask you to find the limit as x goes to negative 1 from the left, which of the two pieces are you going to use? The top piece. Do you agree that that would be where you'd be at for x less than negative 1? In other words, to the left of negative 1? Okay, so when I try substitution by putting a negative 1 in there, what do I get? I get 2. Okay, this is asking for the limit as x goes to negative 1 from the right. So which of the two pieces am I going to use if I'm to the right of negative 1? The bottom piece, right? Yes? So if I stick a negative 1 in there, what do I get? What do I get? 1. Okay, so there's your left-handed limit. There's your right-handed limit. And since those are different, what's your two-sided limit? Does not exist. Easy. Agreed?